Hi everyone, welcome to part 2 of this week's session on moderation and interaction effects. So in the first session we ran through the basics of testing a moderation hypothesis when we have two continuous predictors. So in this second part, what I want to do is look at our analysis options when we have combinations of categorical and continuous predictors. So we'll start with a second example. So let's consider a research question where the research design set up to test it involves a categorical predictor and a continuous moderator. Okay, so let's take our researcher who is interested in alcohol consumption intentions again. So again, they're pretty convinced that there's evidence that norm perceptions predict people's own alcohol consumption intentions. And they're thinking about, well, how do we perhaps intervene to change this? And they develop an intervention that is designed to change or correct people's misperceptions of how much other people around them actually consume alcohol. And specifically, it gives people information that people tend to drink a lot less than you might think. So in other words, the norm of the group is lower than you think, and that should in turn pull down people's own alcohol consumption intentions. But we also saw the interaction between norm perceptions and identification. So they also reasoned that that intervention will be most effective when people also identify strongly with the group. Okay, they're therefore more concerned with and sensitive to information about what other people in the group are doing. So in modeling terms, we have a predictor, our norm intervention. So that has two levels. So we have a low norm condition where people are given information that people consume less alcohol than you might think. And that's compared to a control condition in which people are given no information. So it's got two levels. And we have a moderator, which again is in-group identification measured continuously on a self-report questionnaire. So let's look at how we might approach testing that moderation hypothesis. So let's go back to our data set. We're going to have a look at general linear model again, GAMLJ, general linear model. Once more, intentions are our dependent variable. And this time we have the norm intervention here, which is categorical, as the main predictor. So because that's categorical, it gets entered as a factor, as we remember. And our moderator is identification, which is continuously measured, so it's entered as a covariate. So what we need to do, again, is ask for not just the two main effects, but also the interaction between them. I'm just also going to check once more that identification is mean-centered. It is, that's what we want. I'm going to ask for the simple effects of the norm intervention at different levels of identification as the moderator. And then finally, I'm also going to ask for a plot of the effect, a plot of the interaction. So I want to see the effect of the norm intervention on the horizontal axis broken down at different levels, separate lines, for identification. So let's just have a very quick look at that plot. So it's a little bit truncated on this end because intentions could actually vary from -3 to 3. So what I'm going to do is click on the plot, click on more options, and I'm going to say or force the figure to have a minimum value on the y-axis of -3 and a maximum of 3. Okay. So there we have a better representation of the effects when taking into account the full range of the scale. Okay, so that's not a statistical issue really, that's just a data presentation or data visualization issue. Okay, so what do we see? Well, here's the overall output. Again, we've got the sort of the ANOVA version, if you like. Let's move myself up here. We've got the ANOVA version and the regression version in the same output. Again, it's just exactly the same thing, just with different sorts of information in there and presented slightly differently. So we've got the main effects of the norm intervention and of identification, neither of which were significant. Okay. But the interaction between the norm intervention and identification is significant, 0.008. So one way or another, the norm intervention is having an effect that depends on the level of people's identification with the group. Let's look at the simple slopes. Again, this is the ANOVA version and the sort of regression version of the output table. But again, it's sort of redundant information. It's the same information. So what do we see here? Let's look at the simple effect of the norm intervention whenever identification was low, when people didn't identify very strongly with the group. There, the effect of the norm intervention is actually significant. And it's only significant when identification is low, not when identification is at its mean level or when it's high, okay, which kind of goes against the prediction of the researcher. So just to point out here that these the simple effects can be written up either in regression or sort of ANOVA format. So for example, you can report the estimate, the regression coefficient, the standard error, and perhaps the t-statistic and p-value, or the beta, okay? Or you could report it as you would an ANOVA effect. So there's your F ratio, the numerator and denominator degrees of freedom, the p-value, and the partial eta squared. Really, it doesn't matter functionally which of those you do, as long as it's consistent. But anyway, in terms of the actual substance of the effects here, it looks like, against the prediction, the effect of the norm intervention was only significant when identification was low, not when it was high or at its mean level. So let's look at the figure and try and see what's going on there. So again, this is the slope or the effect of the norm intervention. So the low condition is here and the control condition is here. So remember, it was only really having an effect when identification was low, okay, the blue line. So what looks to be happening here is that intentions are descriptively actually higher in the low condition, in the intervention condition, than they were in the control condition. So not only was the interaction not quite of the shape that the researcher predicted, actually the norm intervention itself seems to be having what you might call a backlash effect. People who see the norm intervention are actually reporting, at least when they have low identification with the group, they're actually reporting higher or stronger alcohol consumption intentions compared to when they're given no information. So who knows what the reason for that might be? It could be that if you're not particularly into the group, then you might not particularly care, or you might be irked or be sort of bothered by information about the norms of the group, as if it's an attempt to influence you, and you push back against it by saying you're going to do the opposite. Whatever the reason for the effect is, the key point is that to understand the effect as a whole, what we need is not just a test of the interaction, and not just in turn a test of the simple slopes, but also some idea of how the descriptive pattern looks. Okay, so it's here only by looking at these and the values that they're plotting that we can see that the norm intervention has an effect when identification is low, but that's actually in the opposite direction to what you might have predicted. The norm intervention seems to have actually produced stronger, not weaker, intentions. Okay. One thing I'm going to do actually is just pop back to the output, because this plot here is plotting actually 6 specific values. Okay, that's where these come from. In order to get what those values actually are, what you can do is ask for or go to the estimated marginal means drop-down menu. You'll remember that from the ANOVA and mixed models sessions. So if we ask for the estimated marginal means for the norm intervention by identification, the interaction, we will get a table of values. Okay, so what we get is the estimated value, the mean, the estimated mean, in the low condition, whenever identification is low, whenever it's at the mean level, and whenever it's high. Okay, and it's those 6 values that are being plotted here. Okay, so let's take this value here, okay, which is in the low condition, whenever identification is low, low condition identification is low. It's that value there, 0.468, which is being plotted here. Okay, so that's where these values come from. If you use the estimated marginal means table in an analysis like this, it will give you the estimated means, okay, that are plotted then in turn in the figure. Okay, so if you wanted the actual values that appear in the figure, that's where to get them. So what about a third example here? What about when we have instead a continuous predictor, but the moderator this time is categorical? So let's go back to a slightly different research question, one that we looked at in the regression lectures, and specifically an organizational psychologist interested in what predicts commitment, people's level of commitment to an organization, their employing organization. And in particular, they were interested in whether people's annual salary predicted commitment to an organization. So in other words, maybe you get paid more, you're more committed to your organization. But they were also interested in testing whether that association, the extent to which salary predicts commitment, is actually stronger for male rather than female employees. So here we have a model that specifies a predictor that is continuous in terms of how it's operationalized, salary in pounds, and a moderator that in this case is categorical. And because people only reported as male and female, it's actually binary in this case. And the outcome variable is commitment to the organization. So let's look at how we would approach that. So let's go to a second data set, which is actually the data set that we worked through in the regression sessions. So here we've got several variables, but the ones of interest to us are, let's just look at GAMLJ, general linear model again. We've got our outcome variable, commitment. We have annual salary as a predictor, which is continuous, so it's entered as a covariate, and a moderator, sex, which is entered as a factor because it is categorical. Now it's just a matter of doing the similar steps that we have in the previous analyses. We want to make sure that we have not just the main effects, but also the interaction between them. I'm going to ask for the simple effects of salary, the simple slopes of salary, broken down by participant sex. And I'm going to ask for a plot of the effect as well, just to visualize it. So I want to see the slope of annual salary on the horizontal axis, broken down with separate lines for male and female participants. Let's just have a quick look at that plot. And again, because Jamovi doesn't know otherwise, it doesn't know that annual salary can't be less than 0, unless people actually do, in some cases, pay to work for an organization. I'm just going to truncate this so that it actually starts at 0 rather than giving us predicted values that are minus numbers. So I'm going to go to more options for the plot, and I'm going to specify that on the x-axis the minimum value should be 0. Okay, there we go. So let's consider the output here. So we have, first of all, our main table of output. I'm looking at the regression style table here. So we've got a significant effect of salary. So the higher people's salary, okay, the more committed to the organization they tend to be. But that is not in turn moderated by participant sex. Okay, so the interaction between salary and sex is not significant. So just out of interest, let's look at those simple slopes. In this case, we can actually see that the slope of annual salary on commitment, the slope of annual salary on commitment is actually significant for female employees, but not for male employees. So we have a significant effect for one group, but not for the other. Now, the key thing here in this case is to avoid the temptation to interpret those effects as differing from one another, because the non-significant interaction effect tells us that they are not, okay, or we should not regard them as so. So just because the slope for female employees falls one side of the significance threshold and that for males falls on the other side of the significance threshold, it does not mean that those two slopes, those two effects, are different from one another. Okay. And again, just looking at the figure that we produced, we can see that the slope is like descriptively a little bit stronger for female employees, but the slope, okay, for male employees falls within the confidence band for female employee slope and vice versa. So visually we can see straight away that they shouldn't be regarded as different from one another, these two slopes. So finally, let's consider an even more complex design, designs that have more than two predictors. So let's go back to our researcher who's interested in predicting and perhaps even shaping people's alcohol consumption intentions. So perhaps they add a little bit more nuance and complexity to their model and predictions. So what they're suggesting now, or interested in testing, is that the intervention that corrects, in other words, pulls down perceived alcohol consumption norms will reduce people's own consumption intentions, especially when they identify strongly with the group. But now in turn they're suggesting that that is going to depend also on whether participants themselves like consuming alcohol. So whenever their own attitude towards alcohol consumption is positive. Now I don't mean positive like in a normative or value-laden sense, but rather simply that they themselves like drinking alcohol compared to when they don't like drinking alcohol. So here we've got a model that has a main predictor, let's say the norm intervention again. We've got that same continuous moderator from the previous time we looked at this, in-group identification, but now we've got a third predictor, a second moderator, which is people's attitude, people's own attitude to alcohol consumption. Again, this is continuous, measured perhaps using a self-report questionnaire measure. So what we're saying here is that the effect of the predictor is going to depend on the first moderator, but then in turn, only at specific levels of the second moderator. So what we're saying here is we're expecting a three-way interaction. The effect of this depends on this, but only in turn at specific levels of this. So let's see how we would approach that. So back to our first data set here. I'll start from scratch to set this up. So we're going to gamma J3 again, general linear model. We're once again looking at intentions as the outcome variable. We have the norm intervention as our factor because it's categorical. We have identification as a measured variable, a measured predictor, so a covariate, and likewise now attitude as another measured predictor, a covariate. In the model, again, we have to ask not just for the main effects of those three things, but all of the possible interactions between them. So I've selected them all, and if I just click this arrow, it will give me all the possible interaction terms between them. It gives me what you might call the full model. So if you remember from the analysis of variance and mixed model lectures, whenever we have three independent variables in a full model, that gives us 7 possible effects. We've got the 3 main effects, we've got the 3 possible two-way interactions between that set of predictors, and finally we've got the 3-way interaction. The 7th effect is the 3-way interaction between all 3. Okay, and that's what we've got now. I'm going to ask for the simple effects of the norm intervention, now this time not just broken down by identification, but also by attitude. And I'm going to finally ask for a plot of the effect, just to visualize it. So again, the norm intervention is on the horizontal axis. That's what I'm interested in the effect of, if you like. I'm going to again ask for separate lines, so broken down by identification, but now in turn also by attitude. And to do that, we specify that we will have separate plots of this two-way relationship, this two-way interaction, broken down in separate plots according to whether people's own attitude is low, 1 standard deviation below the mean level, or high, 1 standard deviation above the mean. Okay, So here again, we've got not one plot, but three plots. Okay, we've got the norm intervention by identification interaction, but now specifically when people's own attitude is low, when it's at the mean level, and when it's high. Okay. Just one final thing here, just as with the previous analysis, with the plot, I'm going to make it look a little bit better as a representation of the effect by asking for the full range of possible y-axis scores. So that ranged from -3 to 3. It's taking a little while to update. There we go. Okay. So let's just walk through that output. So again, just to say, just as we saw in three-way analyses of variance or mixed models, we have 7 effects. The 3 main effects, the 3 two-way interactions, and the 3 two-way interactions and the 3-way interaction between all 3 of the predictors. Okay. What we see is we've got a main effect of attitude. That interaction that we saw in the previous analysis between the norm intervention and identification is still significant. Does that in turn depend on attitude, tested by the 3-way interaction? No, it doesn't. Okay. So in other words, attitude, that second moderator, third predictor, second moderator, does not qualify or moderate the 2-way interaction between the norm intervention and identification. We can look at the simple slopes. So again, we have quite a few simple slopes or simple effects here because we're looking at the effect of the norm intervention broken down by low, mean and high levels of identification, and in turn by low, mean and high levels of attitude. So for example, this is the effect of the norm intervention whenever identification and attitude are both low. Okay. What we can see is that the only significant slope, the only significant effect or near significant effect is again when identification is low rather than high. Visually, again, this makes it clear, or it's a good visual representation of the non-significance of the 3-way interaction, because that 2-way combination of the norm intervention and identification just looks really similar regardless of whether attitude is low, mean levels or high. Okay, so we get no effect when identification is at the mean or high levels, but a little bit of a backlash effect, at least descriptively, whenever identification is low. Okay, so that hopefully has given you a foothold in how to approach testing moderation and interaction hypotheses when you have different combinations of categorical and continuous predictors. Now I just want to close off by adding some caveats to what I've shown you. The first is that a reminder that interaction effects, and this isn't just interaction effects, I should stress. Interaction effects are just like any other effect. They can be large or they can be small. So just like any other effect, like a main effect, it's really important to think about the size of effect that you might expect. Okay, and if an effect is likely to be relatively small, we may need a relatively large sample in order to gain sufficient power to reliably detect it. Something that goes alongside that is the fact that whenever we do find an interaction effect that itself is relatively small, it may not readily replicate if we don't have sufficient power to find that effect time after time. A second caveat is that, now I guess one positive way of framing what I've gone through in this session is it's a way of freeing you up to test moderation hypotheses when you don't have categorical or directly manipulated independent variables. But that comes with a caveat in itself. So whenever you have predictor variables that are not experimentally manipulated, and that includes the moderator variables, we need, just like in any other analysis that is true of, you need to take or have a lot of caution when it comes to causal interpretations. And thirdly, and this is, I guess, a little bit more specific to the possibilities opened up by the sorts of things that I've talked about in this session, is there is a temptation that you need to resist that comes with these sorts of analysis options. And that is when testing a variable that you expect to predict the outcome variable that's non-significant, an approach such as this can open up the temptation to try and rescue that by testing post hoc and without theory whether the effect in turn is moderated by other variables. So maybe my manipulation doesn't affect the outcome variable. Well, maybe that's because it only actually works for a specific subset of the sample, for example. Now, that is problematic for various reasons, but one of them is quite simply that it can lead you to end up focusing on meaningless or unreplicable effects, or so-called chasing noise. And that's really into a fourth, slightly more general sort of formulation of that caveat, that these techniques open up possibilities for exploratory analyses when we have lots of predictors in our data set. So in other words, analyses that involve sort of looking at combinations of predictors without a very good prior theoretical reason for why that is meaningful to test. Now, I don't want to suggest that that's bad in and of itself. Actually, exploration can be a very sensible thing to do when you have a big data set, as long as you're clear that what you're doing is exploring rather than hypothesis testing. Because the key thing there is you will ultimately need to take into account the possibility of large inflation of type 1 error rates. With enough testing, searching around, with exploratory analyses, the chances are that something significant will emerge sooner or later, even if it is in effect meaningless and there's no true effect. Okay, it's just one of those instances that have cropped up, in a sense, by chance. So a key message at the end of this is maybe it's not just something that's particular, I guess it's especially relevant or comes into focus, particularly with these sorts of analyses, but I think it's also true of anything that I've covered in this module or any analysis technique in general. Approach it with two things. On the one hand, with caution, especially regarding what it means, what the output of an analysis means for causal interpretations, but also approach it with theory. Good reason for why your model is a preferable one and a sensible one and meaningful one to test. And ultimately, the number one goal here is not just to avoid communicating to other people something that's potentially misleading or untrue, but also fundamentally to avoid kidding yourself that there is something there when there isn't. Okay, so that's it for this session, and indeed for the course. I hope you found it of some use, and thanks very much for watching.